So, when we are, hi there. I thought Erin, I would give her a shout out. Hey, Erin. Okay, so when we put a substance in water, it comes apart into its Na and Cl aqueous. That's what happens. Okay? Then I add it to, let's say we've got Pb NO3 2 aqueous. What that means is really similar thing. Here's my beaker. Here's my water. I got Pb and my charge is +2. And I've got NO3 -2. Now I've got 2 of those, so I got to put 2 NO3s in here. So I got 2 for every 1. Does that make sense? Yes, sir.
How do we know the charges?
Well, because you go backwards, remember? That's a -1. Does that 1 match that 1? Then that 2 has to be a 1 up there. Just like you did when you named them.
Wouldn't it be charged like -1 then?
No, well, so it's going to be Pb, oh, I put 2. Oh, sorry. My bad. Good catch. So Pb +2 aqueous plus there's 2 nitrates, 2 NO3 -1 aqueous. This is what's happening in this reaction. Okay? This is what we don't see this, but that's exactly what's happening. They are breaking apart into their ions. Then we put them together in one other beaker, and what happens is the lead finds itself attracted to the chlorine, and the sodium and the nitrate stay in solution. So the lead and the chlorine come together and make a solid and sit at the bottom. And the sodium and nitrate stay up in solution. And we write it like this up here. NaNO3 aqueous plus PbCl2, solid. So we know these guys come apart. Na+1 aqueous plus NO3 -1 aqueous. But this guy doesn't come apart, so I got to keep it together. PbCl2, solid. This is all what's going on in those beakers when you mix 2 things together. Does that make sense? Yes? Now, one thing we didn't do is balance it, so we need a 2 over here. So there's 2 of these and 2 of those. And then we need a 2 here, so there's 2 of these and 2 of those. Okay? Now, this is what we call a complete ionic equation. It means we have shown how everything comes apart and goes together in the reaction. It's a complete ionic equation. But I don't care about complete ionic equations. It doesn't matter to me. I just want to know what is being produced. That's all I want to know. So what's being produced on the product side over there? Well, sodium nitrate, but is it really being produced? It's still in solution, isn't it?
Lead chloride?
The lead 2 chloride. If it's a solid, a liquid, or a gas, that's a product. If it's aqueous, I don't give 2 hoots about it. Okay? So, what's the same on both sides? The sodium, I cross that out. 2 sodiums, 2 sodiums. The nitrates are also the exactly same on both sides of the reaction. Nothing else? No? Those are called spectator ions. Spectator ions are part of the reaction. They're just watching. Just like a spectator in sports. They have no effect on the outcome. They are just there watching. The sodium and nitrate are spectator ions. They have no effect on the reaction. They have no effect on this being made. They're just there. So this is what's being made. PbCl2, solid. And the two things that make it up are 2Cl minus 1 plus Pb plus 2. And these guys are both aqueous. We're just showing the parts that come together to make the product I want. This is called a net ionic equation. It tells us what we really need to know. Okay? Logan, please wake up. Sit up. So net ionic equations tell us what's actually happening, just like my paycheck. I get a gross amount in pay. I get my net pay. I never want to see what my gross pay is, because when I see my net pay, it makes me very sad. Okay, if they take out all the taxes and fees and this and that, it's like, oh my gosh. So I just want to know, what am I bringing home? That's all that matters to me. How much can I take out of my ATM on a daily basis? That's what I want to know. My gross means nothing to me, because that gross amount is, most of it's gone other places. Does that make sense? So we want the net ionic equation. We want to know just what's being made. Now I've gone to overhead. We'll do a few more. Sean, do you have a question?
The 2
Uh-huh.
So like on the bottom part, it has 2Cl, and then it goes to Cl2.
Yeah.
And it's also like +2 for the lead.
Yeah.
So like, how does that work?
Well, you got 2 chlorines here, 2 chlorines there. 1 lead here, 1 lead there. You're just saying, when you see the charge right there, it shows it's aqueous. It shows you had a partner somewhere else. But the only part I'm interested in is that these 2 parts. I don't have to say this was sodium, because sodium is a spectator ion. It doesn't matter. I don't have to say this was with nitrate. It doesn't matter. It's these 2 coming together that matter. Does it make sense? Let's do a few more. I think it'll make sense when you see this. Okay. Yeah, I'll put it like that. Hope you can see.
So the 2 from the sodium will carry over to the chlorine?
Yeah, let me show you 1 second. Let's do another one. Let's see. Let's ask those questions. We do them. Okay. I think it'll make more sense that way. Maybe it will. Maybe it won't. We'll see. Okie doke. Oh, here we go. Okay. So let me walk through it a little more slowly. Okay. So there we are. So let's say we have NaCl, aqueous, plus AgC2H3O2 aqueous, and it makes NaC2H3O2 aqueous plus AgCl solid. This is a really terrible example because we don't have any coefficients, so that was not a smart thing to do. But we'll just see. We'll break it apart. Okay? Are we good? Okay, now I'm going to do a bad thing. I'm just going to say no. I'm going to do something else. I want something that's going to show you why. I don't know why I did that one. That was kind of dumb. Okay, I know. Oh, I had to write so much. It was terrible. Okay, so let's do this one. Here we are. So we do SrOH2 aqueous plus H3P. Oh, give me a second. I know, I'm sorry. It's been a bad morning. let's see, hydroxide. We'll do, give me 1 second. Hydroxide, group 1 metals. So we'll do strontium hydroxide and chromium nitrate. There we go. That makes me feel better. Okay. So it's going to make strontium nitrate, which would be aqueous, plus chromium hydroxide, which is going to be solid. Sorry, I ran out the paper. Can you see it though, okay? CrOH parentheses 2 solid. Now anything that is aqueous gets split in half. We got to balance it first. It's all balanced. I'm just not good at making these things up, am I? Okay? So I've got Sr plus 2 aqueous, right? Splitting this 2 in half. How many hydroxides do I have? 2. So I put 2 OH minus 1 aqueous. You see what I'm doing? I'm just splitting this up. I really would write this down if I were you, because you're not going to remember it. Okay? Plus, we split this guy in half. I'm waiting. Cr plus 2 aqueous plus 2 NO3 minus 1 aqueous. So I just split my aqueuses in half, right? Does that make sense? Now I split this aqueous in half. Sr plus 2 aqueous plus 2 NO3 minus 1 aqueous plus CrOH2 solid. I don't break up the solid. The solid is my product I'm looking at. I cannot break it up. Does that make sense? Yes or no? It does? Good. What are my spectator ions? So strontium. What else? Nitrates. Anything else? So whatever's left is my reaction. So I have 2 OH negative 1 aqueous plus Cr plus 2 aqueous yields CrOH2 solid. Does that make sense? Yes or no? This is my net ionic equation. Yes? Are we good? Okay. I find a good one. It's not before I do anything else. Okay. This won't work. Okay. May I? We'll do one more. Well, you should have waited a few seconds ago. Oh no. Okay, so here we go. Okay, so let's look at this guy. Mg Br2 aqueous plus KOH aqueous yields what? What two things are we made from this? Magnesium what? So Mg, what's my formula going to be? OH Aqueous or solid? Aqueous. It's going to be aqueous. You know how to read your solubility chart? Make sure you look at that. And then it's going to make what else? KBr, aqueous, or I was asking you a question. This is solid, sorry. And KBr is aqueous. Okay? Then we balance it. How do I balance this thing? Put what, where? Here? 2? Here? Okay. So 1, 2, 1, 2. Now, what is my product that's being made over here? This is my product, right? This is what I'm worried about. I don't give her 2 hoots about the other stuff. Not 3 hoots, I don't care. Okay? So write down what your product is. Mg, OH, parentheses 2, solid. What things make up magnesium hydroxide from the reactant side? This magnesium here, Mg, I need my charge, plus 2 aqueous, plus what else? Good, 2 OH, negative 1 aqueous. Sean, is this answering those questions you had before?
I don't know. I'm trying to write it all down.
Okay, I'll give you a second to write it down and look at it.
So if that's say like the product was like iron hydroxide parentheses 3.
Mm-hmm.
So it'd be 3 OH.
Yes. Perfect. Yes. Does that make sense?
So we don't have to break them all up.
No. If you can do that, if you can see the product, you do not. I don't like complete ionic equations. They're a pain in the derriere to do. Okay. So far, so good, right?
Why is there 2 OHs?
Because one, there's a 2 in front of it here. There's 2 times the hydroxide. There's 2. Does that make sense?
Yeah.
Okay. I want to show you one other one. Now, if you still have the one I think we wrote down first, I think that's what I'm going back to. So if you have it written down still. So if you have, that is strontium or magnesium? Strontium. Yeah, the very first one I did with you guys. Strontium.
You want us to rewrite it?
Yeah, and if unless you have it, down it's fine. All acids are aqueous. And it's going to make H2O liquid plus SR3PO4 2 solid. First thing I want to do is balance it. How do I balance this guy? Org. So where? Here? The 2 there. 3 here? Oh, 3? If I got 2 times 3, it's 6 hydrogens. Remember, this is HOH. That's how you look at it. So I got 6 hydrogens. I only have 1 hydrogen here. Remember, this is my hydroxide.
Oh.
Here's a hydroxide over here. So I need a 6 here. And I need a 3 there. So 3 strontium, 6 hydroxides, 6 hydroxides. 6 hydrogens, 2 phosphates, 2 phosphates. right? Yep. Now, what's my product on this side? Well, my strontium phosphate, Sr3PO4 2 is a solid, but what else? Can I split my water in half?
Yeah.
I can. I can only split what in halves? They have to be aqueous. They have to be aqueous to split in half. Is water aqueous? No, water's a liquid. So I've got my H2O here. So I have to bring both of them down. And what makes up these two products? Everything else on the side, right? So you got to break all these in half. 3SR plus 2 aqueous plus 6OH minus 1 aqueous. I'm writing it like this because it won't fit. Plus 6H2 plus 1 aqueous, H2. 6 H's aqueous plus 2 PO4 minus 3 aqueous equals that. I just split both these in half. Does that make sense? And it makes these. Anything that's a solid, a liquid, or a gas cannot be split up. That tells me it's a reaction. Yes, ma'am.
I'm confused on the PO4.
Uh-huh.
Like, not on that side, on the other side. Why is it for, like, on the...
Why is it what now?
Why is it on the bottom?
Oh, I just ran out of room on this side.
No, like, it's like 4 on the bottom and 3 on the top.
This 4 minus 3?
Yeah.
PO4 is phosphate and it's got a minus 3 charge. I break them back into the charges, to their ions.
Like,
So if you look at phosphate, it's
like
PO.
right on.
Okay. How are we doing? Good? Okay. So let's give this a try. Okay.